Hello everyone, welcome to this webinar from Responsible Computing. The topic of today's discussion is going to be on generative AI and sustainability. So here is the agenda of today's presentation. Firstly, I'm going to give you guys a quick rundown of what we're going to do today. Next up, we have the Generative AI white paper that's going to be presented by Cheranellore Vasudevan, otherwise known as Vasu from IBM, and Louis Freeman, also from IBM. Then we'll have a brief discussion from Chuck Byers, a presentation rather, on energy use and carbon footprint of Gen AI. And then after that, we're going to have a panel discussion where we will have a number of esteemed speakers here. So we'll have Vasu, who led the creation of the Responsible Computing Generative AI white paper. We have Chuck Byers, who runs our sister program, the Industry IoT Consortium. We have Louis Freeman, a project manager from IBM, who is also instrumental in the creation of our white paper. We have Douglas Ramsay, who is a managing partner over at Axial Global Associates. Doug also provides quite a bit of assistance on funding, specifically state-sponsored funding for some of our members here in Responsible Computing. And we're also very happy to be joined by Dean Nelson, who is not a member of Responsible Computing, but is rather one of our partner organizations, iMasons. So we have a liaison going with iMasons to collaborate together towards a more responsible and sustainable infrastructure when it comes to IT. So some of the topics that we're going to cover today will now be covered by Louis. So Louis, I'm going to hand it over to you and you can run through the generative AI white paper.
Yeah, thank you, Michael. So as Michael mentioned, Responsible Computing with contributions from the Industry IoT Consortium is releasing a white paper related to responsible generative AI. And some of the topics that the document covers is basically the trustworthiness of generative AI. It touches on issues like bias and hallucination, as well as the impact that Gen AI will have on labor and employment, and issues currently seen with copyright because of how the data, the model is trained. It touches also on how this new way of doing things is going to affect the way we learn and are educated, and on the environmental effects of having these huge models, foundational models, trained. We also discuss about how the efforts that are being done to regulate and govern the new era of generative AI. And finally, the document shows some examples of responsible use cases of generative AI. So with that said, on the next slide, I want to talk about the concerns that exist today with generative AI in more detail. And the first concern is the amount of data that goes into training these foundational models. These models basically take data from many different sources, from internet pages, news services, and also collections of art and literature that in some ways are copyrighted, and then video and audio recordings as well that are copyrighted. And because of the diversity of the data and the huge amounts of it, it is very difficult to kind of curate the data for bias. And then, as I mentioned, some of the data that is being used to train the foundational model sometimes is copyrighted. So there have been concerns about the originality of the data that the model basically provides, and lots of concerns about copyright violations and royalty payments. Right? One of the main concerns with neural networks and the way that they are trained is that they are not actually absorbing the information as such, but rather putting weights on different nodes on a neural network. So when you ask the model to tell you where the information came, they basically cannot tell you. And another big concern is hallucination, where because of the fact that you trained the model with certain data, if you ask a question that is outside of the realm of that data, the model will try to give you an answer, right? And so it will make up answers. And this is because neural networks are not self-awareness. They cannot tell you, they cannot differentiate between true or lies, right? The second big concern is the impact on labor. Because of the automation that generative AI brings, it is going to disrupt, and it's already disrupting a lot of the job markets. And basically, Gen AI is another period of transformation like what we saw in the past with the agricultural revolution, the industrial revolution, and then the IT revolution. And one of the big differences here is that compared to the previous revolutions where most of the jobs were white collar, the jobs impacted were white collar, for Gen AI, the impact happens to be in blue collar jobs. So professions like software development, accounting, legal, medical professions, customer service are being impacted as we speak. And this is happening at a way faster pace than what was seen on the previous revolutions. So, and just as a final point, generative AI is not going to basically take over your job. There's still going to be the need for somebody to be there asking the right questions to generative AI. But certainly a person who knows how to use and leverage generative AI will take that job from you. So that person who doesn't embrace Gen AI will basically be left behind. And with this, I want to pass over to Vasu, who's going to talk about the next slide. Oh, sorry, Vasu. There you go.
Oh, sorry. Thank you, Luis. While the white paper mostly talks about some of the concerns, some of the cautious approach we need to take in adopting responsible AI, so this is generative AI, we also wanted to point out the positive impacts of this particular technology also. The technology is very powerful. And then if we can channel it to the right use cases with proper guardrails, we can really benefit from the power and the capabilities that are unleashed by this particular technology. And then we just kind of wanted to list out a few of those scenarios here. There could be much more, but the paper covers some of these different aspects about how it can help in, for example, unleash the human productivity and a faster discovery of drugs. The drugs that typically would have taken years, like maybe 10 to 15 years, have been, we are able to accelerate the drug discovery, maybe into, maybe 1 year or even less than a year and so on. Quicker bug-free software code generation is another example where where software engineering is one of the most expensive aspects when you want to develop applications. That's another very promising one, especially some of the translation from legacy software to the new styles of software and so on. For example, the COBOL to Python, COBOL to Java, and so on. Then it can also unleash or help. We express the concerns about the IP and copyright, but at the same time, it can be a good tool, just like the CAD for engineers. There can be, these tools can be for artists and creative writers and other people also. So there are some positive aspects of this power of this technology. And also it helps to really, in medical diagnosis or fault diagnosis, this can be very, very beneficial. And also in education, I think I was recently listening to a TED talk by Sal Khan, founder of the Khan's Academy, that how generative AI can be useful to have one-on-one education, one-on-one tutoring, which is a dream for most of the teachers. And then also about how it can be helpful for learning impaired children, how they can better ways of learning. All those are possible because of this technology. And then also finally, just want to touch upon the generative AI for sustainability too. I mean, when we are always worried about the power consumption, the carbon footprint that is left behind by the generative AI models, foundation models, which which are massively large models, as all of us know. But it also can be used to really help environments also in many ways. One of the examples would be to have the clean energy generation, optimizing that and reducing the consumption rates appropriately, again by optimally controlling the consumption by different devices, or maybe optimally determining what could be, or predicting what could be the consumption levels. And then recently, IBM and NASA announced a geospatial foundation model to really predict the climatic changes so that we can take appropriate action and then so avoid the loss of property and loss of human lives and so on. And also to be helpful for supporting better logistics. So these are some of the things that could help the positively impact the sustainability of our world, or surrounding or environment around us. While of course there are still some concerns about the power consumption and the power requirement or power hungriness of these models, which I think probably Chuck is going to talk about in the next few charts. Over to you, Chuck.
Thanks, Vasu. As in all advanced and disruptive technologies, generative AI, or large language model AI, is useful for good and evil. And it has valuable attributes to society and civilization, and dangerous or potentially dangerous attributes to society and civilization. So one of the ones that I think is going to be an important, immediate, and easily measurable impact of generative AI is the energy used by the enormous data centers and numbers of processing elements necessary to perform generative AI. And that comes in two phases. One is a model training phase, where I might collect in terabytes or petabytes of data from the internet and use neural network technologies and very sophisticated algorithms to crunch those into a model. And then that model gets sent out to what's called the inference phase, where I take customer input and I use that to make results with that AI model and return them to the customer. The energy use of this is going to be staggering. Many of you have heard that Bitcoin and cybersecurity mining processes take about the amount of energy that the country of Argentina does. I would expect that in a fully realized AI-enabled civilization, we might do 10x that to run the AI infrastructure. Let's take a little bit of a look at a calculation of exactly how much energy that requires and exactly what the carbon footprint and environmental impact of that might be. This study was done in a sidebar in the paper, and the paper that Vasu mentioned, you can certainly go and download that and see the details. And as all things related to energy calculations, your mileage may vary. There's a lot of assumptions associated with this. And depending upon how hard you step on the accelerator, or the AI equivalent thereof, how efficient your drivetrain is, or the AI equivalent thereof, you're going to have very different results. But one reasonable set of calculations is shown here. So the GTP3 model, which is the basis for the very famous ChatGTP system that in some ways kickstarted the current craze in generative AI, it requires 3.14 times 10 to the 23rd floating point operations, or flops. And for those of you who appreciate scientific notation, you know that is a really, really huge number. And this is just to calculate a single model. And we might need to calculate hundreds or thousands of those models. So let's take a look at an infrastructure that would be useful to recalculate that model once a week. We might want to do that, for example, if I had lots of people who were sharing a set of computing resources, a set of servers in a cloud data center. Or I might want to do that in order to take the same model from the same customer, but recalculate it once a week in order to keep the data that's feeding it current. And I challenge you to go to GTP and ask it to tell you about the danger of Chinese balloons. It'll tell you about heavy metal poisoning and danger to wildlife and stuff like that, but won't say anything about surveillance balloons, because the model was trained before that news event. And that's a danger consistent across these AI systems. So training the 3.5 model once a week The calculation is that we might use a certain kind of NVIDIA server, which is called the DGX H100. It's kind of the state-of-the-art computer. It's about the size of a microwave oven. It takes about 8 or 10 times the power of a microwave oven to run that. And in order to recalculate the GTP3 model in a week, we need 195 of those servers, or about 49 racks of them. Each of them draws a little over 10,000 watts. So the total of this, plus the infrastructure to cool and connect it, is about 2.5 million watts. 2.5 million watts at the current electrical grid average of about 0.85 pounds of CO2 per kilowatt hour. That means that we're going to blow 171 tons of CO2 per week out of the smokestacks of those power plants in order to keep that data center running, in order to train that model. That's the carbon footprint of around 1,300 households, or around 5,000 people. So it's a significant impact. And of course, there's going to be thousands of such data centers continuously calculating and recalculating AI models. And then there's going to be thousands or perhaps millions of additional data centers that are taking those models and running the inference that the AI models are used to provide the value that they generate. So the bottom line is, this is a very significant energy expenditure, and we better be careful about how we manage that, what the sources of energy are, and what the efficiencies are that we insist on in the infrastructure. If we go a little bit forward, I'll just show you kind of what a block diagram of this thing would look like. So there's an AI server that has about 6 of these big graphics processing unit chips in it. And then there's racks and racks and racks of them, 49 racks of those servers, along with some auxiliary equipment. And then there's a power and cooling apparatus that has to keep these things from melting down. 10,000 watts is a lot. So there's 40 or 41,000 watts in each of these racks. That's a lot. And we need to blow a lot of air on it, or maybe even use liquid water or oil cooling to make that happen. And then we hook all these things with various interconnect systems through to the internet users and to the data that it's crunching on in order to build the AI models. That's how you build a data center. And of course, variants of this will be existing throughout the civilized world. I hope I haven't been, fear-mongering and saying, oh no, carbon footprint's ugly and this is going to cause all kinds of additional problems, because I think that the benefits of generative AI, especially when it comes to sustainability, are going to far outweigh the carbon impact of actually running the infrastructure. And just some things that sustainability can do. We can certainly optimize the placement of renewable energy resources and the way they connect to the power grid. We can improve the reject rate and quality output of manufacturing, greatly reducing the scrap and energy usage of these manufacturing facilities. Now, we can potentially reduce the need for travel by being smarter about when we meet or how we go places. Certainly logistics networks, I think Vasu already mentioned that, a great opportunity for us to cull the waste out of all of the shipping and warehousing that we do. And the bottom line is, I think that we're really just going to increase the efficiency of pretty much everything that we do, and the environmental impact of those human activities ought to be positive. And that's the hope. That's one of the things that the Industry IoT Consortium and Responsible Computing and the Digital Twin Consortium are working on, is to make sure that we're using our powers for good as opposed to evil. That's the end of that particular talk. Right now, we're going to enter the question and answer phase of our webinar. So those of you who have questions, if you go to the dashboard, there should be a little question mark. And if you click on that, you can leave us questions and we'll do our absolute best to answer them. I have a couple of prepared questions to get us started. So let's get our panel online and take a look at those prepared questions. The first one really is, let's ask you all, what can we do to use generative AI techniques to support green initiatives or ESG kinds of goals that corporations and individuals might have? Who'd like to go first on that one? Dean, we haven't heard from you yet. Would you like to talk?
Yeah, actually, maybe what I can do before we jump into those pieces, I think it's important to help people understand a baseline about what you just walked through. So at Infrastructure Masons, we're a professional association of the builders of the digital age. So think of the underlying engine that enables the Internet of everything here. So these are the biggest companies in the world: Google, AWS, Meta, Microsoft, all the co-location companies, etc. We've all come together really going after 4 initiatives, and one of those is focused on sustainability. And so we created this thing called the Climate Accord, and that is about decarbonization of digital infrastructure. Okay, so that's a really important component of this, but let me start with the baseline. As you shared, those data centers that are built, we have today 7 million of them, 7 million unique locations. Okay, these are ones with a street address, from the street corner to a gigawatt campus, and various sizes of data centers. They have 105 gigawatts of capacity built. This is UPS generators, et cetera, all the capacity that's backed up to be able to enable these types of workloads to happen. They consume 594 terawatt hours of energy. That represents 2.4% of the global energy draw. So just put that in perspective. Whenever it leaves your phone or any device, anything in between that happens is part of digital infrastructure. And the reason I put that in there is that 594 terawatt hours of energy was 2021. All right. All of the generative AI components that are coming out right now, the forecasts are that we're going to be tripling digital infrastructure's overall capacity globally, tripling. Okay. So when you've got 100 plus gigawatts of capacity and the demand coming in from generative AI and the basics just from the actual infrastructure to run this is already predicted at 38 gigawatts. So these numbers are staggering. And just to put that in perspective, you know, the electricity took 50 plus years to get, you know, global basically adoption. It's taken less than a year for us to have global adoption, less than a year for the world to engage with just ChatGPT, one use case, right? Generative AI use case. And as everyone is sharing, there's so many more that are coming out, and the pace of that is incredible. So the reason I put that out there is that we've got an underlying infrastructure that's about to expand massively. And remember where that's expanding. We've got established markets like the Americas and Europe, but I was just in Africa. Africa has a total of 350 megawatts of data center capacity for the entire continent. 350 megawatts. That's like 1/3 of a small campus from Meta. So you just get the idea here. That entire continent's going to explode with 50 plus countries, right? Then you look at India. In 2019, they had 400 megawatts of data center capacity for 1.3 billion people across that entire country. They're at 800 megawatts today. That was before generative AI. There's 1.3 gigawatts in the pipeline. So when you think about it, tens of gigawatts are happening, and the emerging markets are going to be insanely fast at doing this because guess what? Data sovereignty, all those other pieces have driven people to build things within those continents, within those countries. And then you just layer on generative AI. And it's staggering the amount of stuff that's going to be built. So what is extremely important for us at iMasons and through the Climate Accord, and by the way, climateaccord.org, is that we are about to build 2 times or 3 times more capacity. How do we make sure that we build that sustainably and operate that sustainably? So structure-wise, what we have is the Climate Accord is focused on 3 things: the materials. So this is the concrete, steel, copper, et cetera, and the embodied in carbon associated with actually building those buildings. Then you have the equipment inside of it. This is the mechanical, electrical to the IT to the network, the stuff that fits in there, the embodied carbon of those products, that equipment. And then the energy source and the carbon intensity of that energy. That is a holistic view of what we're looking at when it comes down to the engine that enables all this work to happen. I haven't even talked about the work yet, just the engine underneath this. So we, by the way, the 250 companies that are actually involved in this have a combined market cap of over $6 trillion. The biggest companies in the world are focused in on how do we build this sustainably. And that is super important. And so that unity is what I think is the most important decision, because as we build this, when we make that decision, we've got a 50-year impact. You're building a building with a bunch of capacity, it's going to be used, right? So I think that the underlying components of this are really critical. Now you start to overlay, how do we operate it? What use cases are going to be on it? And how do we utilize it? And Chuck, as you were saying, that was really, really important, because we can't just keep building stuff and use 50% of it. We got to maximize that utilization. So every watt that's consumed for every embodied carbon footprint aspect of it are meant for good, positive work. Because in the end of it, we need to be carbon, net zero carbon for all three of those, and ultimately negative carbon for them.
Mm-hmm.
So sorry, I just wanted to give a baseline here for us to start driving some of the conversation, because we're hitting on 3 or 4 different angles.
That was magnificent and real important points. I think a lot for us to think about. And those of us who are working to lead this industry, it's our responsibility to get this right. Absolutely.
Absolutely.
Anybody else have anything else? Yes, Doug, I see you got a question.
Yeah, so a lot of different thoughts, and Dean touched on so many good points, and really it's the compounding factor of what we're looking at with generative AI right now gives me reason to pause. And that reason to pause is, are we ready from the industries that we're trying to track, and are we going to create instances where we duplicate the hallucinations or the bad modeling behaviors because of a lack of the ability to sensorize or collect the original data that we're looking at to get to sustainability across these different sectors. So if you start to go down scope 1, 2, 3, you get down to number 3, and Dean was touching on this, right? The embodied carbon in the different industries. Go into your average mine, your refiner, your smelter, your extruder, your batch processor, and you're going to find that industry 4.0 is decades away, right? These guys are operating, with very little sensor data. The models are chalkboards and assumptions, right? And those chalkboards and assumptions are driving a lot of the base models that the generative AI is picking up. And now we're getting this issue where we're getting some very lazy modeling happening, right? That lazy modeling happens now faster than it could last year. and it's got to triple, quadruple, quintuple, we're don't pick a fight with Moore's law. These are bad ideas, right? But we're not ready. And we're not ready across some of these fundamental industries. And what really keeps me up at night is, where does those fundamental industries happen, right? In the past, your primary materials industries tended to be a first world issue. It's not a first world issue, right? A lot of those industries for mining have moved into the third world, okay? Those mining operations, those manufacturing operations have actually created a lot of wealth. This is what supports schools, clean water, the ability to build urban infrastructures. Now we're going to come after them with these digital tools to say we want to be able to track down all of your carbon, and we're going to create architectures which say thou shalt, move towards this decarbonization, that they don't have the ability to censor this up. This is the second generation of a digital divide that we talked about back in 1998, 1999. We were worried about broadband. I'm worried about, when we chase sustainability without the good models, the ability to lower the cost of sensorization, and we falsely train hallucination into these models. Who benefits from this are your big model makers, right? And I don't want to name names, but we can all imagine, there's a lot of people that have a lot to gain by turning up to be the certificate issuers, right? With the most robust models. These models are going to be compound error. So this is where I turn back to the idea of, how do we get accurate data pumping into these models across these big manufacturing organizations, or big construction, or big energy, or server farms, where we can reduce the cost to sensorize really, really close to zero, and we can start to create very robust data spaces. And here I'm going to use the European language of data space through the ISDA, the Gaia X initiatives, now the Manufacturing X initiatives, to say that we need to create data sharing enterprises that make it very easy to swap proprietary data to train better models, right? Most industry, like going to a little town in outside of Kuala Lumpur that's a chemical making town, they've been doing this for 40 years. Do they have sensors, for the plant that's going to be pumping out chemicals to Saint-Gobain? The answer is generally no. Right. And so they're relying on a third party now to generate that model, and the AI is going to run with it. I want to get to some of that blocking and tackling. Right. And I really think get the cost of sharing data down to zero and the cost of censoring, so we can avoid this potential pitfall. Because it's we've heard about this in different forms, right? Building bias into our chat GTP models, whether that be political or other. That's dominated the front pages of the New York Times and the Washington Post, right? Let's avoid that when we talk about carbon.
Excellent.
Can I add some points to that, Michael?
Go, Vasu. Vasu may have frozen. In the meantime, let me ask an audience question. And thank you for audience questions. And you can enter them into the Bright Talk sidebar. There's a question mark, I think, on the right of your user interface. So this comes from Shen Condran, and he asks, would there be a possibility that the updating of the generative AI becomes less sustainable in the future, as it might have to take more energy, like, as I mentioned, the energy of 1,300 households to update a model? What do we do about that? And let me give you one more point about the potential of that danger. And there's this thing called the East-West plan that China is working on. And basically what they're trying to do is to put all the data centers in the west of the country where the coal reserves are, in order to support the populations in the east of the country. Think about the analogies of that.
You touch it with a needle.
Yep, I understand. But think about the analogies. And I'm not saying that they're the only culpable party here. I mean, Amazon, Meta, Facebook, AWS, they're all potentially in that same boat. But who's got some more perspective on the question from Shane?
Happy to jump in on a little bit of that one, because all of them are represented within the Climate Accord. And just to make sure that I think everyone's clear, all of them are committed to how do we get to a carbon-free future. The challenge here is they don't know exactly how to do it yet. And I love that, by the way, the humility. We have to come together as an industry to be able to tackle these things, because individually we cannot solve it. So that's why the Climate Accord is so critical. But what you were just outlining, think of the supply chain. So everything back from the smelters, right, mining the minerals, etc. When you start to look at that carbon footprint, one of the most important things is I need data to be able to make informed decisions, which means that the equipment itself needs to have a carbon footprint for its generation. So the concrete, when it gets to a site, what is the carbon impact of that concrete? Like what did it take? What's the embodied carbon? The steel, the copper, the glass, the other pieces. So there's a company called forgot the name of it, Building Transparency. Buildingtransparency.org is basically tracking materials on projects and has a database specifically that says, for this project at 350 Cermak, they use this construction company with this concrete. They know the exact embodied carbon footprint of what happened to build that building. That's important, right? Because now we got data that's driving that to understand the underlying embodied carbon footprint. Next is EPDs. And are you guys familiar with the carbon label? I mean, this happens on a lot of things. Take a nutrition label for food. We put that on there so we can make informed decisions, right? So we know the sodium and the carbohydrates and saturated fats, etc. When you look at, I'm buying a server, what is the actual carbon label for that server? That is the embodied carbon aspects of it, of everything to get to that point, as you were sharing. Okay, so now when we look at what the manufacturers are doing, and they're part of our climate accord, they're looking backwards and saying, how do I decarbonize that actual supply chain? all processes and steps to say, I'm using clean energy to even do the manufacturing, clean energy to do the production, clean energy. So you're just constantly reducing the carbon. And that carbon label will now tell you that product, just like a price, just like performance, has a carbon number associated with it. Okay. And the reason I say this is that now take the 250 plus companies. How are we doing this? We're requiring carbon labels. We're requiring the tracking of the materials so that we can go back and actually lead with our wallets. That will drive the behavior to say, I'm getting lower and lower embodied carbon of that capacity. Okay, so as we triple infrastructure, the buying decisions will drive the decarbonization, because to participate, you need to have a lower carbon product or location. Okay, so that's one. And then when you start to think of these big models, the biggest in the world, you got Microsoft, Google, Amazon, right? Think of them. They're building the massive GPT-4, 4.5, right? All of those pieces. It costs them a lot of money to run that. There's going to be a forcing function economically for them to say, I can't afford to do that, or I got to get a lot more creative. So that's going to also be a really good thing for us, because no matter what, the dollars will drive the behavior. So because they've got publicly committed sustainability objectives, it's no longer just a nice to have for sustainability. They're held accountable at the board level and publicly for what they actually committed to get to net zero carbon. That's a forcing function. Second is the cost. All right. Third, adoption rates are insane. Everybody's using it. But I want to also make sure that people understand there are all other models, because not everybody wants to go back and take, as we said at the beginning, their legal data and put it into OpenAI. They're going to have a private LLM as a service. They're going to train their private models, right? So they're going to have an independent piece of this. Well, where's that going to run? It's going to run in co-location facilities on third-party hardware that has the exact same thing I just outlined. We've got to get the underlying infrastructure lined up so that we can make sure that every one of these things that's run continuously becomes more and more sustainable. In other words, less and less carbon for every transaction.
Excellent. Anything else to add on those topics?
Yeah, I just want to point something out. So following on that comment, I mean, not every single application is going to need a know-it-all model, right? You can actually reduce the size of the models to basically be able to curate the data to eliminate bias, eliminate hallucination, and also reduce the carbon footprint by doing that. So.
Yeah, I think I will add on to that one, to the same point. We can have tiny foundation models, and I think already, recently, Google has announced that runs on your mobile devices, right? And with of course some sacrifice in the accuracy level, but not significantly lower accuracy. So I mean, the trend would be have distributed models and doing some specific functions which may potentially consume less power for its training as well as for its inferencing. So that's an interesting trend that's coming up now. We talk of this multi-billion parameters, and then now it's bringing down to something that can be run on your mobile phones. That's
trillions of parameter, right?
Yeah, that is correct. And interesting to notice that optimizing all of those things and how the energy use and carbon footprint and sustainability impact of AI could potentially itself be an AI problem, right? There's too many moving parts for any human or even smart collection of humans like the Climate Accord to get this all right. And maybe AI bootstraps its own success and its own responsibility through careful application of AI techniques to optimize all of this stuff. The problem is prompt generation for that optimization run. What do you ask it to optimize? And most everybody who's paying $100 million for this kind of infrastructure is going to ask it to optimize profitability. That's not the right question. We need to optimize profitability in the lens of sustainability.
So Chuck, I can't let that go. That's just too juicy.
Let it happen. Okay, go.
So I think you're 100% correct, right? I'm a true believer, in pursuing the net zero dream. Are we as a planet aligned? Even coming out of COP28 this week, I think the short answer is no, right? Despite what came out of the announcement, and then your China example is exactly correct. The fastest path to get us there is not to turn to regulation. If we think this is going to be a stick as opposed to a carrot, we're missing the mark, right? These companies are going to spend this money and going to start to look at generative AI to support their operations, are going to go after the low-hanging fruit. And the low-hanging fruit is going to be profit, and it's going to be efficiency. And it's not going to be a Six Sigma or some kind of Kanban system. They're going to go chasing, really simple things like, can I have enough data just to track yields? Okay. Really simple. Depending on the nature of the company, this can be multi-billion-dollar returns to the bottom line.
And when you think about the AI assistant now, one of the first things you want to be thinking about is, what documentation do I have that I can train an assistant for my domain? So you're first going to take an assistant and point it at the documentation that you've got. This is an example in HR where, it's very possible now, and most people on this call will be familiar with RAG and so on and so forth, where you can sort of ingest a lot of documentation, and then you can start to converse over those topics that are in that documentation.
Right.
So
basically,
the
context
base level for an assistant is, here's the documentation that you can already provide answers from, right? And you can get an assistant up and running very quickly now, conversing on your topics, right? And we'll talk about this a little bit later on.
Yeah, I think
you can then start to think about, okay, that's a fine base, but what if I want to sort of override behavior, right? Because I've got particular flows that are very important to my business, right? So this is a flow which is, again, an HR example, applying for disability protection, right? And there's a lot of questions to sort of clarify, well, are you looking for this kind of protection or that kind of protection? If it's this kind of protection, then here's your answer. Purely informational, right? There's no transactions taking place. There's no lookup in third-party systems taking place.
I'm not sure who's talking.
Inside the AI,
I think somebody else has their microphone on for some reason.
those actions will override.
There we go.
Okay, it was interesting nonetheless.
It was, yeah. It lined up to what we're talking about. Wait, what HR example? That was interesting.
That's okay.
All right,
could have just been crosstalk across the Bright Talk platform, and I apologize for that. Let's go a little bit deeper into what roles regulation and guide rails and government might have in this space. You've already touched on this, but do you think that government should be a high touch or light touch? Do you think that altruism of corporate world is going to be adequate? Do you think that we need to impose big sticks and big fines and carbon taxes, or what's the answer in terms of the right way to apply government resources, maybe grants, maybe pressure, in order to achieve these desired outcomes?
Should I go last or first? So I don't want to talk for the next 15 minutes.
Why don't you go first, Doug, since you're sort of an expert, having worked with Sesame and the U.S. Department of Energy.
Light touch, open architecture, open source, as close to zero cost as we can possibly get, the ability to collect data. That's the gold standard, right? Right now, the biggest constraint that we have right now is not organizing the data, not can we run computation, can we run servers. It is a third party or a middleman who's going to put in a commercial system to help you collect data to be able to train these models. And that can be punitively expensive. And we have too many politicians and regulators right now that are assuming that that's an easy thing to solve. Because they're assuming that's easy to solve, they're setting targets way too fast for the companies to be able to resolve that, and it trickles down the value chain or down the supply chain to a point where a small to mid-sized business is going to be run out of business. Light touch, open architecture, get these standards down to a very, very simple baseline. And we're pursuing that with OPC UA. We're pursuing that through SESME with the SESME profiles. It's happening through Platform Industry 4.0 with the asset administration shell, and on it goes, right? And this is what has rolled into now the 10-country coalition around manufacturing X to say, how do we get the cost really close to zero to collect the data, to then go forth and train the model, avoid the original sins. Okay, I'll stop.
Well, that was really useful. Who else has something to say about the role of government or the way that impacts could be received through government?
Yeah, one good thing about this technology is that I think people like politicians and the leaders of the government and technologists are well aware at the beginning itself that the dangers, or if it is let out of control or without control and so on. So we have taken early steps. I mean, the fear mongering, the initial stages can have some benefits actually. We have a cautious approach as opposed to what happened in the social media platforms. And then there was monopoly, there was there were no proper regulations to control and so on. So this step is to really come up with appropriate regulations, appropriate guardrails putting by different governments in different countries. That's a good step to go with. I would consider this as very similar to the FAA in FDA, like Federal Aviation Agency and Federal Drug Administration in US, right? There we can have some control on what's happening in the industry for the overall benefit. Of course, there are some always lobbying and so on.
In that particular instance, you're really talking about a Hippocratic oath, right? First principle is do no harm. And watch out for Chesterton's fence. What were the rules that we set in originally that we forgot why we set them in place, right? So totally agree with you, right? The governments are going to move way too fast because we're rolling out these expectations and these targets to get to zero by 2050, right? That's what came out of Glasgow. Couldn't agree more.
So I have a perspective on this. I think that like any tool, it can be used as a weapon. And that's like when you look at generative AI, that's one of the risks we've got is how many good people and bad people are leveraging this. And the challenge is that the bad people can actually accelerate it very quickly. And I think that there's got to be some kind of oversight, guidance, whatever, something that will allow us to be able to use these tools for good to go against the bad, but also to make sure that as we're watching that, there's a way to go back and stop some of that. So I think to me at the highest level, this comes down to how is generative AI used? To me, that's where governments and others must get involved, because the only way that we can go back and alignment on definition of what that means. I don't know if I want to be in that room, but that's a very difficult thing to do. But either way, to me, that looks like the way to approach it. From the other side, we got to be really careful not to regulate down into the industries too fast. And the reason I say that is like the FAA and others came out of crisis. We had a whole bunch of plane crashes. We had train derailments. We had a bunch of things like that people died, right? Mm-hmm. So they went in and used that as a forcing function to say, we must do better. I think that the first point, we have to make sure we're thinking about this, but man, this is a very big, very fast topic that's going to be very difficult for government to get their teeth around, or their arms around and their teeth into. We have to do that correctly. But I would say that industry consortiums are one things like what we're doing with the Climate Accord. What we're doing right here with responsible computing is to go back and make sure it's clear what we're looking at and how we solve that problem. But then the other one is that I think there's a self-regulating forcing function that's going to happen. One of the biggest challenges right now, if you look at Microsoft and the others, is they're spending a mountain of money to train these LLMs, and they're repeating it multiple times a month. Just to put that in perspective, right? You talked about ChatGPT-3, that's 1,250 megawatt hours to actually train it once. ChatGPT-4 is over 4,000 megawatt hours. So there's an economic forcing function, I believe, that's going to make them now say, guess what? LLMs, we can't keep training this way. We have to go back and do deltas and smaller amounts. So they're going to get more efficient just because of the economics. Okay. And then you take the other regulations like COP28 and others that are saying, here's the carbon motivator. people are going to start to buy with their wallets again, right? Lead with that to say, what's not only my lowest price and where the capacity is, but also what is the carbon equivalent to that actual service that I'm leveraging. So if there's a forcing function on that side, it will be driven by buying decisions. So I think there's some other levelers here that will happen naturally, because it's just too damn expensive to run these things in this manner. But so the industry needs to drive things, and that's why consortiums like this are so critical, because we can self-regulate and drive that. Government's relations, we need to have some tie to this to inform, to make sure that the decisions that are being done are not too punitive and not too regulating, not too limiting with what needs to be done. So this is why that industry consortium and collaboration between the two, I think, is critical.
Or to put it a slightly different way, not too ill-informed. The regulators are chasing certain political agendas, right? So we have a moral obligation to tell them what we know. Anyway, hey, Chuck, are there other questions? I don't want to ignore the audience.
Let's take a look. I don't think there's a whole lot going on in the chat window right now. We have time for one or two more if you want to put one in. I do have a quick follow-on to that. We talk a lot about energy, and that's certainly one of the biggest potential negative impacts of generative AI. But if you up-level it to the whole responsibility question, social responsibility, and others, there's people who are calling for sort of an equivalent to Asimov's 3 rules of robotics for AI. And Microsoft's got 6 of them, principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. And I think we all care about all of those deeply. And the question is where there's dichotomies or trade-offs or conflicts among them. And Asimov's rules of robotics say, you can't harm a human, and you got to listen to a human unless it violates the first rule. I suspect that there's going to be an interaction among whatever is derived from these kinds of rules for AI in similar complexities. And I hope that gets universally adopted, but diligently defined. And we're still in the process of that. And certainly that's among the things that our cluster of consortia are really interested in working towards.
Yeah, let me take a shot at it. Being responsible, it also involves about how you can, able to explain your decisions and explain your solution. That is one thing. And then also how you have acquired that knowledge, right? Basically, any expert, right? So if you ask a doctor, if you ask an expert lawyer, any expert in any domain, that's what we expect. So similarly for here also, just like our labels for the drugs, we need to have labels on some of these models about on what data it was trained on and how it was trained on, as well as who were all involved in the training and what algorithms were used there. And then also about how much carbon footprint occurred for the training. Right? So these things matter for people, the consumers or the users, to decide which model to use, and then for what applications it can be used. That will give an idea about what are the limitations or what are the boundaries of the capabilities of these particular models. And that helps a lot to enforce some credibility. And that also leads to the need for coming up with appropriate metrics and measurements on really evaluating these models, and also come up with some standards. Of course, unless you meet certain standards, it cannot be put in production. Like just like I think a drug that cannot be put in public for public usage until you have completed all these tests and certification and so on. So we need to gear towards those steps about how to measure the quality and reliability of these models, as well as how we can be as transparent as possible, as well as how we can really come up with some standards or certification process here. Just want to know the thoughts of other people here.
Excellent. Well, thanks for that, Vasu. We're rapidly approaching the top of the hour here. I'd like to give every one of our distinguished panelists thanks for coming and for the great perspectives you shared. And I'd like to give you 1 minute to sort of summarize, what you think are the biggest challenges, the biggest potential benefits, and the possible approaches that we can use to balance that out. Louis, would you like to go first? You're on mute, sir.
Thank you. Yes, I'd like to point out that to the public, don't be afraid of Gen AI. Embrace it, and learn what the carbon footprint is for each one of the models out there. If you choose to pick one, I think it's on every one of us to make sure that Gen AI is sustainable and carbon neutral. So.
Excellent. Thank you. Vasu, would you like to go next?
Yeah, just looking at again, want to put a positive spin on this one. Any technology has got its pros and cons, and look at the ability, the capability it could provide for communication, better communication, translation or interpretation, summarization, and those kind of things. And also how it can be very helpful for advancement of science and technology, including medicine, right? How it can have a big positive impact in education for one-on-one tutoring, helping people with cognitively impaired, and all, those are all, and of course, supporting the sustainability too, better weather prediction, better weather models, better logistics, and so on. So let's look at that positive aspects of this technology with proper guardrails. Question. Thank you.
Thank you. Next, let's go to Doug.
So I'm going to wheel us back to the first section of the paper. And the first section of the paper talks about IP and copyright. This is the biggest unaddressed threat with generative AI right now. And we're not really digging into it. If you can run millions and millions of quantified variations of, let's say, a material set or a manufacturing process, forget the infringement on copyright or IP. You can race to the patent office with novel claims so quickly that you can outpace all of your competitors. So set the sustainability aside for a second. Let's realize for the corporations what they're really looking at here when they're looking at generative AI. They're suffering when they call up their legal department from a patent system that was quite literally invented in the 1840s, right? Where an innovation cycle would be 20 to 50 years. You build a light bulb with a certain filament, and you'd wait another 30 years for a better filament to get built, okay? So how many filament designs can you do, in the course of 3 seconds with a good generative AI model? Millions, okay? So we need to have a very serious look at the international patent system and how we're thinking about bringing AI into play. That particular piece of the paper, I think, is so damn important. So everybody out there with the corporation, take a look at that and be a little afraid because your lawyers weren't trained on this cycle and this pace.
Perfect. Dean, what you got to say?
I'll just add 2 things, because I completely agree with everything that's been said here. The first one is that I think that how do we find things that are 1 + 1 = 10? And when I say that is just like responsible computing, the climate accord, et cetera. When we come together, we compound the impact of our work. And I think that is super critical. If you're not involved within responsible computing, get involved. If you're not signed up for the climate accord, sign up, because we should be able to use all this information to accelerate our agenda. And that agenda is a carbon-free future when it comes to digital infrastructure that enables all of these things that are happening. That's one. Second is that what worries me is the models and bias. And we talked about this before. If you go to Midjourney on Discord, and you put in something to say, create a picture about an engineer, right, in a lab, something. The bias that comes out of those things that are generated is, here is a male, Caucasian, right, 43 years old, sitting in front of a computer. Again, there's so much that we have to be careful about in how these models are trained to ensure that we don't inflict more bias into a lot of these different things that are happening. And so I don't know exactly how to solve that. My point is that we have to be aware of those things so that when those models are trained, just like Google had to do that with search and everything else, because there was so much implicit bias in things that they didn't even think about until they really looked at it. That's a big challenge in these things, because it's so fast, so iterative on those, and we can perpetuate those biases everywhere in these models that will now have years and years of impact.
Great. I appreciate that. And my last word is I'm an optimist about these technologies. I think that they offer the potential for more good than the danger for more bad in areas like environmental, sociological, geopolitical questions that face the human race. I think that we're going to be ahead of the game for the invention and adoption of generative AI, with a huge caveat. We've got to do it with the care that we've started to outline during today's discussions. Thanks to everybody, and I appreciate everybody's input. Michael, any other instructions for the listeners?
Yeah, just keeping, sorry, my voice has gone a little bit there. Keep an eye on your emails, because we'll be following up with instructions on where you can find the recording of this session, where you can find the slides. And also, if you would like to be introduced to any of the speakers today, please do, give us a reply. We'll come back and we'll facilitate.
And we also certainly offer memberships in our various consortia. And I think you'll find these communities are where a lot of the important work that we've outlined today is really going to happen and really going to stick. So hope that you all join us. And thanks again for your attention. Signing off.
Thanks, Chuck. Thanks, Michael.